expression for effective capacitance of three capacitors are connected in series or connected in, let me take parallel first, what we think discussed in the last class. So I'll take a three capacitors. Let me connect one another. Here one more capacitor, here one more third capacitor. So let me connect. Hmm, I'm just connecting another one with your battery. Okay, so I will take a three capacitors of a capacitance which has a capacitance. So let me take it as a, it is a first capacitor, this is a second capacitor, and okay. So let me write here what are the charges on the three capacitors. So let me take on the one plate, it will be a negative q1, here it will be a plus q1. Similarly here a negative q2, here a plus q2, here a negative q3, and here it is a plus q3. Okay, so these are the charges accumulated on the three capacitors. Okay, okay students, so let me draw the what is the potential difference across the capacitors. It as whatever the potential across these three conductors will be same. Okay, so the because if the number of condensers are capacitors are connected in a such a way that, so the potential difference between these all things, the potential difference between the all these things will be same. Okay, so let me take what are the capacitors here. Let me say c1 c3 are a capacitors, yes or no? So c1 c2 c3 are the capacitors and which are connected in a parallel, which are connected in a parallel. Fine. So now tell me what are the charges on the plates? Yes, what are the charges on the plates?
Q1, Q2, Q3.
Yes. Q1, Q2, Q3 are charges on the what?
Plate.
Capacitors. Let me say is a capacitor.
Capacitors.
C1, C2, C3 respectively. Am I correct? So C1, C2, C3 are the capacitors here, and charges are the Q1, Q2, Q3. Okay. So let me write what is the total charge. Okay. The total charge Q is equals to, can I write it as a Q1 plus Q2 plus Q3? The total charge combination, yes or no? So
Yeah.
but Q is equals to, Q1 is equals to what? Can you tell me the what is the Q?
C1
C1V.
Yes, C1V. Now can you tell me Q2?
Same C2V.
C2V
C2V.
C3V.
Yes, C3V. Okay, so I will substitute here then where Q is equals to C into V, right? So it is the, I can say it as the equivalent capacity combination. Let me write it as
Did
a,
this yesterday, no ma'am?
yeah, someone asked, right? That's what. Some people are just left before it seems. equivalent capacity of combination. Then CV is equals to a C1V plus C2V plus C3V. Okay, let me write a CV, a V common, then C1 plus C2 plus C3. Okay, so let me cancel on both sides. V, then C is equals to C1 plus C2 plus C3. So this is the equivalent capacity of a parallel combination. Okay, is it clear, students?
Yes, ma'am. Thank you.
Okay, if number of what you say capacitors are connected means you need to continue up to n number. Okay, then Cn is equals to C1 plus C2 plus C3, so on up to n. Okay, this is the thing. Okay, clear, Sora?
Supreet, ma'am.
Suprit, sorry. Okay, is it clear, dear?
Thank you.
Okay, can I go for next one, students?
Yes, ma'am.
Just a minute, ma'am.
Yeah.
You can continue, ma'am.
Yes. So let me go for next one. Expression for next one. Expression for effective capacitance effective capacitance of three capacitors connected in series. Okay, let me take three capacitors, students. So let me draw here. So one capacitor, done. Second capacitor, done. A third. All things should be same line, pa. Okay, na? And let me draw here. I'm connecting. See, I'm just connecting with one battery. Mm. Hmm. So I will take a three capacitors. Okay. What is the first and second capacitor capacitance C2 and the third capacitor capacitance is the C. Okay, so here the charges will be a minus Q plus Q minus Q plus Q minus Q plus Q. Okay, so the thing is that when they are connected in a parallel, so the potential difference across the capacitors will be same. So but when they are connected in series, let me see. So whatever the charges flowing throughout the system, okay, whatever the charges flowing throughout the system will be constant or a same. Okay, so let me take here three capacitors. Okay, so the number of condensers or capacitors are connected in a what you say series. The charge across the capacitors is the same. Okay, so let me take here C1, C2, C3 are three capacitors. Three capacitors are connected in series or connected in a series, as shown in figure. Okay, so let me say it as, what is the potential difference across the plates? From here to here, the potential difference across is the V1. Then here to here, it is a V2. Then from here to here, it is the V3. Okay, now can you tell me, a V1, a V2, a V3 are a potential across the, is potential difference across the three capacitors, right? Yes or no? V1, V2, V3 are the potential difference across the three capacitors. Now let me say, what will be the total potential difference across the combination? It will be a V is equals to a V1 plus V2 plus V3. Capacitors V1 plus V2 plus V3, total capacitance. Now can you tell me what is the V1 here? What is the capacitance of a capacitor? C is equals to Q by V. Now can you tell me what is the V? V is equals to Q by
Q
C.
by C.
Yes. Now tell me for this first capacitor. For the first capacitor, what is the V1? A V1 is equals to the Q by,
Q1 by C.
no, the charges will be the same. Okay, Q by C1. Now tell me what is the V2 by
Q
C2.
by C2.
V3 is equals to
Q
Q
by
by
C2.
C3. Okay. Now can you apply, can you write all the values here? So then V is equals to Q by C, which is equal to Q by C1 plus a Q by, sorry, a Q by C2. Okay. Here Q by C2 plus a Q by C3. Okay. Let me take a Q on both side. So Q 1 by C1 plus 1 by C2 or 1 by C3. Okay. Let me cancel on both side Q. Then the equation becomes 1 by C is equals to a 1 by C1 plus 1 by C2, 1 by a C3. Okay. So this is the, I can say it as, so the reciprocal of the equivalent capacity is equal to the reciprocal of the individual capacitance, right? So the reciprocal of the effective capacitance is equals to the reciprocal of the, what you say, sum of the reciprocal of the individual capacitance. You can write here. And then this is the expression for the effective capacitance of a three capacitors connected in a series. Please take it on.
Ma'am,
Yes, ma.
ma'am, for three capacitors connected in series, it is potential difference is same or different, ma'am. It is different, huh?
Series connection. It is V1, V2, V3. See.
Okay, ma'am.
Equivalent capacity is equal to the sum of reciprocal of the individual capacities. Done.
Yes, ma'am.
Yes, ma'am.
Can I go for next page?
Yes, ma'am.
Yes, ma'am.
Yes. So the next one, next part, your numericals based on the capacitor and the capacitance and all. So please do it. Please take it on the question. Yes. Yes. A tall PF capacitor. Question number
10, ma'am.
10. A 12 PF capacitor. PF means what, ma? Picofarad. A 12 PF capacitor connected to 50-volt battery. 50-volt battery. How much electrostatic force? How much static, sorry, energy? How much electrostatic energy stored in a capacitor? Easy one, please do it. Fast. Clear?
U is equal to half CV square.
Yes, please do it. So see, here is a 12 PF. So let me write it as a picofarad. Pico means how much, ma? 10 to the power of minus 12 farad. Okay. So then V is here 50 volt. Then U is equals to half CV square. Then U is equals to half C is the 12
Ma'am,
into
is the answer.
10 power
8 joules.
8 or minus
Minus
8.
8. Minus 8.
Yeah, minus 8 joules.
Yeah, minus 8. Okay, U is equals to 1.5 into 10 to the power of minus 8 joules. Very good. Done. Can I go for next question? Please take it on next question. In a parallel plate capacitor, with the air between the plate, air between the plate. Each plate has a area of 6 into 10 to the power of minus 3 meter square. You write it please. 10 to the power of minus 2 meter square. And the distance between
Minus 3 or minus 2, ma'am?
is a minus 3, sorry, minus 3 meter square. And the distance between the plates is 3 mm, 3 millimeter. Calculate the capacitance of a capacitor. If this connected to a 100 volt supply, what is the charge on the AC plate? What is the charge on the each plate? So a parallel plate capacitor with the area between the plates, each plate has an area of a 6 into 10 to the power of minus 3 meter square, and the distance between the plates or the 3 mm, and calculate the capacitance. Two things you need to calculate here. One thing is your capacitance to the capacitor. Then this is connected to a 100 volt supply. What is the charge? Okay. So try to write whatever the things you know from the question. So they are given. What is this area, right? Area is equals to 6 into 10 to the power of minus 3 meter square. And let me say this, that the d or small r is equals to, okay, is equals to 3 mm. Let me write 3 mm is 3 into 10 to the power of minus 3 mm. So next, v is equals to, yes. Now just first what you need to calculate capacitance. What is the capacitance formula? A epsilon naught divided by D. Okay. Then C is equals to, please calculate this. A is equals to 6 into 10 to the power of minus 3 into 8.854 into 10 to the power of minus 12 divided by D. D is 3 into 10 to the power of minus 3. So let's calculate the C. Then how to do? So you know the C. So where C is equals to Q by V, or Q is equals to C into V. So then C, what the thing you got here, multiply with 100. Please do it.
Ma'am, this is 17.78 into 10 power minus 12.
Yes. 17 point.
770.
Into 10 to the power of minus 12.
Yes,
Minus 12 farad. So 17.7 to 10 to the power of minus 12 into 100. So let me write as 10 to the power of 2. Yes, 100 means. So
I mean, it is 17.7 to the power of minus 10.
minus 10.
Minus
Minus
10.
10.
Minus 10
Minus 10.
coulomb.
Sorry.
Okay. Is it clear? Is it clear, students? Can I go for next question? Yeah.
Some whole 12th of physics is based on electricity only.
Again, not like that. Electric charges is the one part. Second part is your optics. Like light, about light. The ray optics, wave optics, dual light, and yes, ma?
Only these two are there.
No, semiconductors, and the nuclear physics.
Ma'am, atoms, nuclei.
The nuclear physics. Semiconductor technology is there. Second part is the different topics are there. The first part is mainly basically based on your electric charges and fields, current, electricity, moving charges, magnetism, electromagnetic induction, alternating current, based on all current topics. Okay, first part. And the second part, optics, ray optics, wave optics, and based on the dual nature of light, how they behaves, matter as well as what do you say, wave nature, as nuclear atoms. Okay, and after that semiconductors, we'll go for semiconductors. After that communication system are there. Very quite interesting topics in your second year. Okay, done, students? Can I go for next question?
Yes, ma'am.
Yes, fine. Please take it down. Try to solve the number of problems. Question number 12. Key capacitors.
And these are all NCERT questions, right?
Yes, ma'am. Capacitors of capacitance. A 2PF, 2PF, 3PF, 4PF, 4PF are connected in connected in a parallel in that A question. A. What is the total capacitance? What is the total capacitance of a total capacitance of a combination? First question. And the B question. B question. Determine the charge on each plate. Determine a charge on each capacitor when connected across the 100-volt supply. Yes. Try to analyze the question, students. Oh no. Yes.
Ma'am, parallel, we're just supposed to add all of them.
Yes. When I have taken
Ma'am,
three
is the answer 9 PF?
9 PF. Yes. In a parallel, let me take it here, three capacitors. So C1, C2, C3 when connected across the battery. So that is the how many old? 100 old. C1, C2, C3. So when they are connected in a parallel, connected in a parallel. So first A thing will be CP. CP is equals to C1 plus C2 plus C3. Am I correct? So then CF plus 3PF plus a 4PF. Let me write it
Isn't
as
it
a
4F?
yes 9. It is the 4
4F, right? Not PF.
4F 4PF. Sorry, 4PF. So it will be a 9PF. Okay, the combination is a 9PF. Now you need to find out what is they ask like determine the charge on each capacitor. So how to find out here? So the charge on the capacitor C1 is the Q1. So let me write it as on C1 means Q1 is equals to C1 into V. Yes or no? Q2 is equals to a C2 into V. Yes or no? Please will you do like that? Q1. C1 is a, you know already, it is the 2PF, 2 into 10 to the power of minus 12. And V you all to 10 to the power, let me write it as a Q1 is equals to how
Ma'am,
much?
is it 2 into 10 power minus 10?
No, let me write it as a 200 into 10 to the power of minus 12 itself.
Okay, ma'am.
Nice, 12 coulomb. So let me write Q2 is equals to C2 into V. Q3 is equals to C3 into V. Just tell me the Q2, C3 values. Q3,
Ma'am, it's
Q2 value
3 into 10 power minus 12.
3 into 10 to the power. 3 into 10 to the power of minus 12 to the power of 2.
Yeah,
Let me write it as
300
3
into 10 power into
minus
minus 12.
12 coulomb.
It will be 400 into minus 12
Yes,
for
yes.
Q3.
Then what is the total charge on the combination?
Ma'am, we have to add Q1 plus Q2 plus Q3.
Yes.
Ma'am, it will be 900 into 10 power minus 12 coulomb.
Check it once again.
Ma'am, 1000, ma'am.
Why
No.
again? Why again it is 1000?
No, 900 only.
Yeah,
900
ma'am,
into 10 to the
900
power
into
minus
10
12.
power
Q
minus
is
12.
equals to
900, ma'am.
Q1 plus Q2 plus Q3. So it will be a 200 plus 300, 500 plus 400, 900 into 10 to the power of minus 12 coulomb. Q net. Okay. So this is the total charge on the combination. Okay. Is it clear, students? Is it clear, ma? Can I
Yes,
go for
ma'am.
next question?
Yes, ma'am.
Yes.
1 minute.
Ma?
I mean, 1 minute, ma'am. I want to
Yeah,
copy.
yeah.
Okay, ma'am.
Done. Okay. Next question. Please take it on. The three capacitors of each capacitance. Three capacitors of each capacitance 9PF are connected in series. Connected in series. What is the total capacitance? What is the total capacitance of the combination. Second one, B. What is the potential difference across? What is the potential difference across each capacitor? Each capacitor, if the combination is, connected to a 120 volt supply.
Ma'am, for A part, is it 3PF?
Yes, good. What about remaining students? Please do it fast. So here C1 is also a 9PF, right? And the C2 also a 9PF, and the C3 also a 9PF.
9PF.
Yes. So when they are connected in a series,
1 by
by
CS
CS is
equal
equals
to
to
1 by C1 plus 1 by C2 plus 1 by C3.
very, very good.
Wait,
Then 1 by 9, 1 by 9, 1 by 9. So let me write it as a 3 by, sorry, how much this is? A 3 by
3,
9.
1 by 3.
Yeah, 3 by 9. It is a 1 by CS. So 3, 1 by 3. Let me write CS is 3PF. Clear. So second part, what is the potential difference across the each capacitor combination connected to a 120 volt? Now can you do it? Yes
120
or
into
no?
3.
Not into 3. V dash will be the V by 3. It is divided by 3 capacitors. So then what is a V here? Where V is the applied potential. So as a capacitor is identical potential on each capacitor means it should be divided by
To
3.
find Q,
So then V dash
ma'am.
is equals to, huh? What is the potential difference,
Okay.
ma? Okay, potential difference. Okay, then 120 by 3. It will be a 40 volt, not Q. Why you need to find a Q? So when they are connected nation, they already given no the what is the charge over here? Sorry, 9. Okay.
Q is equal to C into V, no, ma'am.
No,
V is
no,
equal
ma.
to Q by C.
Yeah, you can do like that also because no need to do it. All the Qs will be same because all the capacitance are the 9 only. Then students,
Yes, ma'am.
okay, fine then. Thank you all. We'll meet in the next
Thank you, ma'am.
class. I have
Thank you.
Ma'am, bye, ma'am.
I have another. Yeah, bye. Take it down and please leave. Please take down this.
Bye, ma'am.
Yeah, bye. Bye.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.